Hello everyone, this is the solution video for 2023 AMC8 test. Let's do question 1. What's the value of this expression? We just do direct computation. In the first parenthesis, we have 32 plus 2 minus the second parenthesis, which is 8 plus 8. It is 34 minus 16. So the answer is 18. Question 2. A square piece of paper is folded twice into 4 equal quarters, then cut along the dashed line. When unfolded, which of the following figures will match the result? So we notice that the paper was folded along 2 lines. One is the horizontal line that cuts this paper symmetrically, upper part and lower part. The second line is the vertical midline that makes the paper to be symmetrical from left to right. Now, on the right paper, we have the lower right triangular region cut off. That corresponds to, in the original paper, this piece was cut off. Because the paper was folded twice, that means the part which is cut off should be symmetrical in both directions, left and right, upper part and lower part. So the red part should be symmetrical, left and right, and also upper part and lower part. So that's the full picture. So it matches the choice E. So the answer here is E. Question 2. A square piece of paper is folded twice into 4 equal quarters and then cut along the dashed line. When unfolded, which of the figures match the result? So let's see, in this 1/4 of this paper, we have this corner cut off. Let me color by red. This red part is cut off. Now let's investigate every one of the following figures to see what kind of cutting will give us this figure. The first figure, choice A, we just investigate this corner. We see that we need to cut off 2 corners. I shade by red. So it's not the answer. For choice B, similarly, we investigate this 1/4. So we cut this corner. So that's not answer. For C, we look at this corner. So we need to cut off some square in the lower right corner. This is not answer. For D, that's actually not the answer, because if we cut in this way, we should have the cutoff symmetrical. So this is just upper half. It doesn't match. For choice D, it matches because the part cut off is exactly the right lower triangular corner. So the answer to this question is E. Question 3. In this problem, we are given a formula to compute something called wind chill. So it's air temperature minus 0.7 times wind speed. We're given everything, so let's just do the computation. The wind chill is equal to the air temperature, it is 36 degrees, minus 0.7 times the wind speed. Here is 18 miles per hour. The units match, so we just do the computation. It equals 36 minus 12.6, which is 23.4, is closest to 23. So the answer here is B, 23. Question 4, the numbers from 1 to 49 are arranged in a spiral pattern on the square grid beginning at the center. There are 4 shaded squares. The question is, how many of these 4 numbers are prime? So let's just fill the whole grid directly following this pattern. So here's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 30 here. $37, $38, $39, $41, $42, $44, $47, $48, $49. Now we just get all these numbers. These four numbers are 39, 19, 23, and 47. So we know that for prime numbers, there are 3. So 39 is not prime, 19 is prime, 23 is not prime, 47 is prime. So there are 3 prime numbers. The answer here is D. Question 5. A lake contains 250 trout and some other fish. In a sample with 180 fish, there are 30 trout. Assume that the ratio of trout to the total number of fish is the same in both the sample and the lake. How many fish are there in the lake? Let's assume there are n fish in the lake. We are going to set up equation to solve n based on the fact that the ratio of trout is the same in 2 scenarios. One, in the sample. Now, in the sample, the ratio of trout is 30 over 180, which can be simplified to be 1 over 6. Now, in the lake, because there are 250 trout, the ratio is 250 over n, the total number of fish. These 2 fractions are equal. Now, cross multiplication gives that n equals 6 times 250 equals 1,500. So the answer here is B. Question 6. The digits 2, 0, 2, 3 are placed in the expression below. What's the maximum possible value of the expression? So here we'll notice that 0 is a special number if 0 is a base number. Then the result must be 0 because 0 to some power here times whatever number here is always 0. It could not be the maximum number, so we don't do that. So 0 must be one exponent number. And then the expression looks like the following. Some number with 0's power times some other number with a power here. We see that for whatever number with 0 power, the value is just 1, independent of the value of the base. Now we should maximize the right part. Here we have the choices of 2 and 3, so we can just test a few cases. Either you have 2 cube or you have 3 square. They are candidates, and easily we can tell 3 square is larger than 2 cube. So the answer here should be 9. So we can have a 3 square and 2 here. We got 9. The answer is C. Question 7. In the following coordinate system, we are given a rectangle with sides parallel to the coordinate axes. And we're also given 4 points, A, B, C, D. The question is, if you connect AB, we get a line. If we connect CD, a second line. How many points on the rectangle lie on at least one of these two lines. So here we are given the grids, so we can directly draw this line. So for the line passing through AB, we know that the slope is actually 1/3. In other words, when x moves by 3 steps, y moves outward by 1 step. We can just connect AB in this direction. X at 3, y at 1, following this pattern. So you see that it touches the rectangle at the upper left corner. Now for CD, similarly, when x adds 2, y decreases by 1. So following this direction, we can draw the line. And we see that it does not touch the rectangle. It's very easy to see there's exactly one point of intersection. So the answer here is B. For question 7, we can also write out the equations of these two lines. For example, for AB, the slope is 1/3 and it passes through the origin. So the equation for line AB is 1/3 x. Now for the line CD, the slope is -1/2. So it's -1/2 x. But we have the y-intercept at C, which is 10, the y-coordinate. So it's -1/2 plus 10. And now we can see where does this line intersect on the rectangle. For AB, if x equals 15, because for the left vertical line, the coordinate for x is 15. So let's see, x equals 15. We got y equals 1/3 of x, that is 5. So line AB intersects this corner, which has coordinate 15 and 5. It's one point of this rectangle. Similarly, for CD, we can check the left vertical line when x equals 15. We have y equals 2.5. Now that's the point below the rectangle because the height is 2.5. So basically we have a line roughly like that. It's below the rectangle. So totally we have one intersection. The answer is B. Question 8. There are 4 players in the ping pong tournament. So every time there are 2 pairs of players playing. So 1 means win, 0 means loss. So what's the result for teal? So we just look at each column because every time there are 2 groups playing, so that means 2 pairs of players playing. That means we have 2 wins and 2 losses. That means in the notation, we have 2 1s and 2 0s. We basically check every column. Now in the first column, we already have 1, 1, 0. So for teal, it must be 0. For the second column, we have 1, 0, 1. Already have 2 1s, so teal must be 0. On the third column, 1, 1, 0, so it must be 0. On the fourth column, 0, 0, 1, there's just 1, 1, so we need another 1. So teal has 1 here. On the fifth, 1, 1, 0, so another 0. On the last column, 1, 0, 0, so the last one must be 1. And we know that the answer must be A, 0, 0, 0, 1, 0, 1. That's the result for teal. Question 9. Malaika is skiing on the mountain. The graph shows her elevation in meters. Now the question is, in how many seconds does she spend at the elevation between 4 and 7 meters? Now let's mark out the elevation of 4 and 7 meters. 4 is here, 7 here. Now we check which part of the graph belongs to this range. If you draw a horizontal line, we cut off these pieces. The first piece is this curve, and after that, we have the middle piece here, and the last piece here. Now we just calculate the total amount of time. For the first piece, they are totally 2 seconds. Okay, 4 minus 2, 2 seconds. In the middle piece, it's from 6 to 10. They are 4 seconds. In the last piece, it's from 12 to 14. That's 2 seconds. We just add them together. So 2 plus 4 plus 2 equals 8 seconds. So the answer is B, 8. Question 10. Harold made a plum pie. He ate 1/4 of the pie. After that, a moose ate 1/3 of what's left. And after that, a porcupine ate 1/3 what the moose left behind. So the question is how much of the original pie still remained after the porcupine left. So we know that Harold himself ate 1/4, so what left is 1 minus 1/4. Now, based on that, a moose ate 1/3. That means what's left should be 1 minus 1/3. Based on that, we have porcupine ate 1/3, so what's left is 1 minus 1/3. Let's just complete this computation. So 3/4 times 2/3 times 2/3. When we simplify that, it's basically 1/3. So the answer here is D. Question 11. In this problem, we have NASA's Perseverance rover traveled a certain distance in about 6.5 months. We need to find its average speed. Now here, we just need to find the approximate average speed. So let's find the distance. It's a big number, but approximately is about 3 times 10 to the 8th power. Next, we consider the total time. It is equal to about 6.5 months. Let's turn to hours. So that's 6.5 every month, approximately 30 days. Every day, 24 hours. So that's the time and the distance. The distance is in miles. And then the average speed is their quotient. Is the total distance over the total time. It's approximately 3 times 10 to the 8th power over 6.5 times 30 times 24. Yeah, we can cancel this 30 first, and to have that 10 to the 7th power over 6.5 times 24. So it's 10 to the 7 over 156. Approximately, that's 6 times 10 to the 4th mile per hour. And then the answer here is C. Question 12. The figure below shows a large white circle with a number of smaller white and shaded circles. What fraction of the large white circle is shaded? Now let me just assume for each small square, the side length is 1. And we have that the area of a large circle is pi times the radius squared. Here you see that radius is 3. So pi times 3 squared, which is 9 pi. Now next, we consider the shaded part. Shaded area. There are a couple parts. In the part 1, we have a big circle minus 2 smaller circle. The big circle has radius 2, so pi times 2 squared, minus 2 smaller circles. That's 2 times pi. Each circle has a radius 1, so it's 1 squared. So this part has, this is part 1, has area 2 pi. And now we also have the second part that consists of 3 small circles with radius 1/2. So it's 3 times pi times 1/2 squared. In this way, we got a shaded area, which is 2 pi plus 3 over 4 pi. It is equal to 11 over 4 pi. Now the answer comes out as follows. The ratio is their fraction, so 11 over 4 pi over 9 pi, which is 11 over 36. So the answer here is B. Question 13. Along the route of a bicycle race, 7 water stations are evenly spaced between the start and the finish lines. So therefore, these water stations divide the whole route into 8 pieces evenly. So let me recover other water stations. Here's the third one, fourth one, fifth one, sixth one. Now there are also 2 repair stations evenly spaced between the start and the finish lines. So that means they divide the whole route into 3 parts evenly. So we should have 1/3 here, 1/3 here. All right, so the first repair station takes 1/3 of the whole route. And the third water station, the location is 3 over 8 of the whole route. Their distance is 2 miles. The question is, what's the length of the whole route? Now let's assume the whole distance is L. That means the third water station is 3 over 8 L from the start line. The first repair station is 1/3 of L from the starting line. Their difference is 2 miles. So we have 3 over 8 L minus 1/3 L equals 2 miles. Then we can solve L. The left-hand side is basically 1 over 24 L. So we have that L is 2 times 24, which is 48 miles. So the answer here is D, 48. Question 14. In this problem, there are 3 types of stamps with values 5 cents, 10 cents, and 25 cents. There are 20 stamps for each value. It's 20, 20, 20. The question is, what's the greatest number of stamps we can use to make exactly $7.10? In other words, 710 cents. We see that the total value of the stamps is equal to 800 cents. 5 plus 10 plus 25 times 20, which is 800 cents, right? we need 710 cents. 710 cents with the largest number of stamps. Now, on the other hand, we need to make the complement, which is 90 cents, with minimum number of stamps. So we don't choose this stamp. That corresponds to the greatest number of stamps to make 710 cents, right? So let's see how to make 90 cents with the minimum number of stamps. So we must use the large value as many as possible. So 90 cents, let's use 25 as many as possible to minimize the number of stamps. So it's 25 plus 25. We can use at most 325, which gives 75. There are still 15 cents to be added. So that is basically 10 plus 5. So here we need 5 stamps. That's the minimum number of stamps to make 90 cents. So the answer is we use the remaining stamps to make 710 cents, which is totally we have 20 plus 20 plus 20, 60 stamps. We remove these 5 stamps, which is 55. The answer here is 55. Question 15. This one walks half a mile to get to school each day. That route consists of 10 city blocks. So let's compute the length of each block. Total distance is half mile. And that is 10 blocks. This implies for one block, the distance is 1/20 mile. And now let's consider the time. It takes him 1 minute to walk each block. So there are 10 blocks. So the total time is 10 blocks times 1 minute for every block. Means we have totally 10 minutes. Now, today, after walking 5 blocks, he discovered he has to take a detour, walking 3 blocks instead of 1. So 5 blocks, it already took him 5 minutes. That means we have 10 minus 5 equals 5 minutes left. But for the remaining route, distance left, it consists of 7 blocks now. But each block takes 1/20 mile. So we know the distance is equal to 7/20 mile. Based on that, we can solve the average speed in the remaining part. So that's the distance left over time left. So the distance left is 7/20 mile. The time left is 5 minutes, but let's convert into hour. 5 minutes is 1/12 hour. So in this way, we just simplify it to get this to be 4.2 mile per hour. So that's the answer, 4.2. We choose B. Question 16. The letters P, Q, and R are entered into a 20 by 20 table according to the following pattern. How many P's, Q's, and R's are in the table? Now, according to the pattern, we see that the same letters are arranged diagonally. For example, P, this one P, Q, 2Q, R, 3 Rs. Next, P, 4P, Q, 5Q. And we will see there will be 6 Rs following this pattern. But you know that for a 20 by 20 table, the largest number of squares on a diagonal is on the main diagonal. There are 20 squares. So number increase from 1 up to 20 and then decrease back to 1. Based on this pattern, let's count how many P's and Q's and R's. We can just list the numbers for each letter in this following. Like P, Q, R, 1, 2, 3, 4, 5, 6, up to 20 here, and then decrease 19, 18, 17, back to 1. So we just add how many P's and Q's and R's. We see that in increasing parts for P, that's arithmetic sequence. So it's easy to compute. The number here is 70 because the average is 10. Now for the decreasing part is also an arithmetic sequence, and its sum is 63. Now for Q, from 2 to 20, that's 77. From 17 to 2, that's decreasing. We have 57. Now for R, from 3 to 19, that's increasing. This part we have 63. And for the decreasing parts, from 16 back to 1, we have 70. Now we just add them together. For P, there are 133 P's. For Q, there are 134 Q's. For R, there are 133 R's. So the answer to this question is C, 133, 134, 133. Question 17. A regular octahedron has 8 equilateral triangle faces with 4 faces meeting at each vertex. Gem will make the regular octahedron shown on the right. The question is, what number is to the right of Q? Now let's try to fold this triangles to get octahedron. We pay attention to the middle 4 triangles here. Let me mark by red. And let me fold 7 to 4 to get closer. We need some imaginations. So we have 7 here, 4 here, 5 here, 6 here. On the right of 6, that's Q. On the left of 4, we have 3. Here's 1. Here is 2. So imagine that these 4 red triangles makes the lower part of the octahedron. That's the lower part. Let me mark here the lower part of the octahedron. Now, when you fold up this Q, we know that 3 is on the opposite of the Q, and to the right of Q, that's 1, and to the left of Q, that's 2. So in the picture, what's on the right of Q should be 1. That's why the answer here is 1. Question 18. Greta, grasshopper, sits on a long live lily pad in a pond. For any lily pad, Greta can jump 5 pads to the right or 3 pads to the left. What's the fewest number of jumps Greta can take to reach the lily pad located 2,023 pads to the right of her starting point? So let's see the number of jumps to the right. Let me call it to be R. There are jumps to the right. And the number of jumps to the left, let me call it L. Now we have that the total number of movement to the right, which is 5R minus 3L, should be 2023. Or if I move to L to the right, I have phi r equals 3L plus 2023. Now, in this question, we need to minimize the total number of jumps. So we need to minimize R plus L. Based on above equation, we need to minimize both R and L. Because if one number is bigger, the other is also bigger. So we need to minimize both R and L. Now let's check what kind of requirements are there for R and L. So from this equation, we know that the left-hand side is divisible by 5. So phi r is divisible by 5. That implies 3L plus 2023 is also divisible by 5. Now we can basically remove 2020. That implies 3L plus 3 is divisible by 5. In other words, 3 times L plus 1 is divisible by 5. Because 3 and 5 are co-prime, that means we must have L plus 1 is divisible by 5. So L cannot be 0. The smallest L should be 4. Smallest L is 4. And accordingly, we have the smallest R is equal to 3L plus 2023 over 5, which gives 407. And that gives us the answer. L plus R is 411. The answer here is D. Question 19, a equilateral triangle is placed inside of a larger equilateral triangle so that the region between them can be divided into 3 congruent trapezoids as shown below. The side length of the inner triangle is 2/3 of the side length of a larger triangle. What fraction, what ratio? What is the ratio of one trapezoid to the area of the inner triangle? Now let's extend these lines to meet at the center of both triangles. I will call this to be A, B, C, D, and E. Let me call the triangle ABC has area X. The area is X. And BCED, the trapezoid, has area Y. Now we know that triangle ABC is similar to triangle ADE. Now, by the ratio of sides, we have BC over DE is given as 2 over 3. In this way, we can find the ratio of their areas. Triangle ABC, the area, over triangle ADE, the area. It's the square of the ratio of the sides, which equals 4 over 9. But on the other hand, in terms of xy, we know that triangle ABC has the area x, triangle ADE has area x plus y. So x over x plus y equals 4 over 9. Now that implies the ratio for x and y should be 4 to 5. Now the question is asking for the ratio of one trapezoid to the area of the inner triangle. That's basically y over 3x. Okay, in terms of ratio, that's y over 3x, which gives 5 over 12. So the answer here is C. 5 to 12. Question 20. Two integers are inserted into the list. 3, 3, 8, 11, 28, such that the range is doubled and the mode and the median does not change. What's the maximum possible sum of these two numbers? Now let's check the range, mode, and median. So let's see original range. That's 28 minus 3, which is 25. So it should be doubled, right? So we get a new range. Should be 25 times 2 is 50. All right, so we also have the mode, doesn't change. Mode equals 3, unchanged. And also we have the median. So the original median is 8, the middle number is 8. It should not be changed. Okay, the median unchanged means that one number is on the left of 8, one number is on the right of 8. So let me just draw a picture here. One number is on the left. Let's see, number 1 is on the left. The second number is on the right. So the median does not change. Okay. In other words, 1 is smaller than 8. 1 is larger than 8. It cannot be 8 because the mode cannot be changed. Now we need to think about the range. So in order to maximize the sum, we should maximize both numbers. Both number 1 and number 2, right? The number 1 is on the left of 8, which is smaller than 8. So we can have that the max value of number 1 should be 7 because it's integer. The maximum value of number 1 is 7. Now, for the number 2, because we need to double the range, so we should add 25 from 28 to get number 2. That's the largest value of number 2. Should be 28 plus 25 in order to have the new range to be 50. So this is 53. And then we have the max sum. It's 7 plus 53, which is 60. So the answer here is 60. Question 21. Alina writes the numbers from 1 to 9 on separate cards. She wants to divide us into 3 groups, 3 cards on each group, so that the sum of numbers in each group will be the same. So in how many ways can this be done? Now let's first consider the sum of these 9 numbers. It's arithmetic sequence. Easily we can get the sum to be 45. So it's divided into 3 groups. That means each group will have the sum to be 15. Now let's just consider how to get 15 by using 3 numbers. Right, so it's kind of convenient to consider a large number. For example, 9. If we consider 9, it's 6 away from 15. So 9 plus something, so other 2 numbers equals 6. And how to make 6? There are basically 2 ways. Either 5 plus 1 or 4 plus 2. Now let's discuss these 2 scenarios. The first scenario is 9 plus 5 plus 1. The second scenario is 9 plus 4 plus 2. Now we consider other groups. and check if there are multiple choices. Now, for the first scenario, 9 plus 5 plus 1, next we consider the second largest number, 8. So 8 plus 2 numbers should be 15. So these two numbers sum up to 7. All right, for the remaining numbers, we can only have one choice, that is 4 plus 3. So we only have 4 plus 3. And the third group will be 7 plus 6 plus 2. Now for a second scenario, still we consider 8. 8 plus 2 other numbers to be 15. So 8 plus 7, right? In order to make 7, now we cannot use 4 because it's already in the first group. So the only possible way is 6 plus 1. And the third group is 7 plus 5 plus 3. And so we see that there are totally 2 ways. The answer here is C. Question 22. In a sequence of positive integers, each term after second is the product of the previous 2 terms. We know the sixth term is 4,000. What is the first term? Let's consider the first term, let's call it A. And the second term, let's just say B. And then we can use AB to get other terms by a rule. The third term is the product of the previous 2 terms, which is B times A, so AB. Now the fourth term is the product of third term, second term, which is A times B squared. The fifth should be the product of A, B squared and AB. So it's A squared, B cubed. And for the sixth term, it's the product of the fourth term and fifth term. So it's A cubed times B fifths. And this number is equal to 4,000. Let's try to figure out A and B. So we do prime factorization. 4,000 equals, okay, it's 2 to the 5th power times 5 cubed. And obviously we know A must be 5, B must be 2. Because if, for example, if B equals 1, then 4,000 is not a cubic number, so B has to be larger than 1. Be larger than 1. And the only number whose 5th power is a factor of 4,000. We have B equals 2. And so A equals 5. So that's the answer, D. Question 23. Each square in the 3x3 grid is randomly filled with one of the 4 green and white tires shown below. What's the probability that the tiling will contain a large gray diamond in one of the smaller 2x2 grids? Here's the example here. So we can consider 2 numbers. One is the total number of tiling. So there are 9 squares. For each square, there are 4 choices. So we get a total number of tiling equals 4 to the 9th power. All right, next, let's consider how many tilings we have this gray diamond. First, we consider that the location of the diamond. There are 4 locations. Let me show it here. The diamond could appear on the upper left corner. This is the diamond. It could appear on the upper right corner. like here. It could appear on the lower left corner and lower right corner. And we can only have one diamond. There are 4 locations for diamond. 1, 2, 3, 4. Now for each case, we can only have one diamond. For example, like the example in this picture, we have this diamond. We can no longer have diamond here, right? That's impossible. We cannot have diamond here. That's not possible. Not here. So that means we have only one diamond. There is at most one diamond. Now, once we get a diamond, for other squares, they are free. For example, let me take the first picture as example. We have a diamond that determines the upper left 2 by 2 region, but for this other 5 squares, they are free. They can be any tile there. For other 5 squares, they are free. Okay, there are 4 to the 5th ways. For location of diamond, there are 4 choices. So the total number of tiling with a diamond can be computed as their product. Here, number of tiling with a diamond is the product of 4 location of diamond. And for each choice, there are 5 free squares. We have 4 to the 5th ways. That's the number of valid tiling. So the probability is the quotient of these 2 numbers. 4 times 4 to the 5th over the total number of tiling. That is 4 to the 9th. So it's simplified to be 1 over 4 cubed, which is 1 over 64. So the answer here is C. Question 24. Isosceles triangle ABC has equal side lengths AB and BC. In the figure below, segments are drawn parallel to AC, so that the shaded portion have the same area. The heights of the 2 unshaded portions are 11.5. We need to solve the height. Let me just mark these parallel lines. Let me call this D, E, and let this F and then G. Now, each line segment divides this area into 2 parts. Let me mark the first unshaded part is 1. The first shaded part is 2. The second shaded part is 3. The second unshaded part is 4. So we have that 1 plus 2 equals 3 plus 4 because that's the same triangle. Also, we know the shaded part are equal in area. That means 2 equals 3. That just implies 1 equals 4. Next, because the line segments are parallel, we have similar triangles. DE parallel to AC. That just means triangle BEE is similar to triangle BAC. And we can solve the ratio of the side length, which is DE over AC. That corresponds to the ratio of the heights, which is 11 over H. For the second triangle, we can do similarly. We have FG is parallel to AC. That means triangle BFG is similar to BAC, right? And the ratio of the side length is FG over AC. That corresponds to the ratio of the heights. The ratio of the heights for this shaded part is H minus phi. So this corresponds to H minus phi over H. Okay, now we can solve the corresponding ratio for the area. In the first picture, the shaded part, okay, which is just 1, the unshaded part is 1 over the whole triangle BAC is the square of the ratio of the SR length, which is 11 over H squared. In the second triangle, we have 3 over this BAC is H minus phi over H squared. Now we know that 1 equals 4. That just means 1 plus 3 equals 4 plus 3, which is equal to the whole triangle's area. So if we add these two equations, and call it star and the 2 stars, if we add this together, that's equal to 1, because 1 plus 3 equal, the region 1 plus region 3 equals the whole area. So we have the sum of these two. We have 11 squared over H squared plus H minus phi squared over H squared equals 1. Basically, 11 squared plus H minus phi squared equals H squared. When we open this, we have 121 plus H squared minus 10H plus 25 equals H squared. H squared can be cancelled. That means H equals 146 over 10. So H is 14.6. Then the answer here is 14.6. It is A. Question 25. 15 integers A1, A2 up to A15 are arranged in order on the number line. The integers are equally spaced and have the following property. So A1 is between 1 and 10, A2 is between 13 and 20, A15 is between 241 and 250. What's the sum of digits of A14? First, we note that the numbers are equally spaced. That means those numbers make an arithmetic sequence. Right, so we can use the initial term and the common difference to express everything. Initial term is A1. The common difference let's just call it D. Now we can rewrite these three requirements. So A1 unchanged. A1 is between 1 and 10. Now A2 is basically A1 plus D. So A1 plus D is A2 between 13 and 20. The third one, A15 is A1 plus 14D. So A1 plus 14D is between 241 and 250. So we're going to study the A1 D's. Now, let me call this one inequality 1, inequality 2, inequality 3. So if we compare 2 and 3, the difference between 2 and 3 is that we added 13D, okay? We added 13D. So A1 plus 14D minus A1 plus D, that's the difference. This is at least, this is logical to the minimum number in 3 minus the largest number in 2. That's the least difference, which implies 13D is logical to 221. Now we can solve D is logical to 17. Okay, now from the third equation, we can find the other bound for D, because A1 plus 14D is less than equal to 250, and they are integers, right? A1 is between 1 and 10, so it's positive. So we must have that 14D should be smaller than 250, because A1 is positive, larger than 1. Then this implies D is less than 250 over 14. But 250 over 14, it's less than 18. Now combine these two parts, we must have D just equal to 17 because it's an integer. All right, so we fix D. Next, we consider A1. Based on the fact D equals 17, we consider the second equation. It implies A1 plus 17 is less equal to 20. That means A1 is less equal to 3. Okay. And from the third inequality, when we plug in D equals 17, we have that A1 is larger equal to 3, less equal to 12. Combine these two, we see that A1 must be 3. Now we know everything about the sequence. The question is asking for A14. A14 is A1 plus 13D, which gives you 3 plus 13 times 17. This is 224. Now the sum of digits is 8 because 2 plus 2 plus 4 equals 8. And so our answer to this question is 8.